Thanks for tuning in to Stay Sharp with Razorleaf, your secret weapon for all things digital in products and manufacturing. AI is certainly changing the technology landscape and has been evolving the product development process under the form of generative design over the past few years. With AI algorithms showing up in a variety of applications, its use is continuing to expand. In this episode, Eric Doubell, along with Jen Ferrello, pair up with Ramesh Haldarai, the VP of Strategic Consulting for the 3D Experience platform at Dassault Systèmes, to explore the potential of how data science and AI will change the way engineers work. Let's tune in.
Welcome back, everyone, to Stay Sharp, the podcast about all things digital related to products and manufacturing. I am Jen Ferrello, and I am joined today by our CEO, Eric Doubell.
Jen, thanks for having me on.
No problem. And today we are talking about data science and AI, specifically as it affects the future of product development. Joining us today, we have a guest, Ramesh Haldarai. Ramesh is the Vice President of Strategic Consulting for 3D Experience platform at Dassault Systèmes. Ramesh, can you share a bit about your experience and your work at Dassault with our listeners?
Hi, Jen, and hi, Rick and Julianne. Thank you for having me on this podcast. And I'd love to talk about the greatest topic. I think today, a lot of people are talking about AI, but I think we have to focus on how AI relates to product development. And I'm happy to talk about it. I've been with Dassault Systems for more than 20 years. I started my career as a production engineer, and I've been associated with CAD and PLM for a long time, and now with the 3D Experience platform. I'm happy to be here.
Excellent. Well, we're happy to have you too. And I wanted to start. I think you had mentioned in our pre-discussion that AI is a scary topic for a lot of people right now. Why don't we start by defining what AI is specifically? So, did a little bit of research. AI is officially defined as the branch of computer science that focuses on creating systems capable of performing tasks that typically require human intelligence. So it's things like learning, reasoning, problem solving. And of course, because the neural capacity of a computer or a network of computers is almost limitless, AI has the potential to really transform product development because it can just do all of those tasks. If it can automate those tasks, it can do them so much more quickly and explore so many different, for instance, what if scenarios, et cetera. So, but here we're talking about the potential it has to transform product development and the future of work. So I'm interested to hear your input on, where do you see AI going, and where do you see it? How do you see it changing the future of product development?
Well, I'd like to add one thing to that as well. So things like generative design have been in CAD for quite a while, but now AI has become big. How is that? I'd like to understand also, and you do it. How is that different, or how has it evolved?
Yeah, so you're right, Eric. And AI, the algorithms that are used in AI, or what we call classical AI now, because of the new generative AI that has come up, have been there and been used in product development for a long time. For example, if you take the finite element method and the optimization of a variable based on what we are observing with the finite element models, we've used a form of gradient descent, which is a very popular algorithm in neural networks today. So as far as the AI algorithms is concerned, Dassault Systems has been using these algorithms for almost 20 years, ever since finite element modeling started. So that's nothing new in terms of mathematics and in terms of algorithms for most of our customers. I think the recent popularity of generative AI is what has brought everything to the forefront, because now the consumer is aware of the AI capabilities, and the consumer has been brought into the fold. What was in the domain of corporations and experts within companies have now is available to experience for you and I, right? So that's what has changed, I think. And that's why people are certainly interested, everybody's interested in AI. Obviously, there's been a lot of changes from the days that that the algorithms were applied by small teams to where we are seeing AI as something that can be used across the company by all the people in the company. So that's indeed going to be a big change for the future of work for everyone involved.
Where are some of the, because I know that you're right. It's I like the term generative AI because that is certainly what has, right, ChatGPT, right? I mean, that's what kind of announced it to the consumer. To your point, I do know that aside from even within the CAD or analysis tools, there's been things like machine learning, like for instance, identifying, within a CAD system, identifying which processes a particular designer uses most and changing the UI to make those more accessible, more available, and basically follow each designer's usage of it. Where are some of the other areas that perhaps we're not as aware that AI has been around for quite some time?
Yeah. So machine learning has been used for quite a while now, and especially if you look at data science, whenever you have an outcome which is dependent on multiple parameters, there are many algorithms that you can use to figure out how these parameters affect the outcomes. For example, if you have a wear and tear of a particular item, and you see that that's dependent on the number of cycles it is used, the moisture level, the temperature level, and a lot of parameters like this. So there are basic algorithms where you can fit data and figure out how to predict when the actual item will wear out. Mm-hmm. But you can also use a machine learning model, which is very popular now for problems like that. So at the minimum, whenever there is a condition where an outcome is dependent on multiple parameters, and they have a nonlinear relationship between the parameters and the outcome, then all these algorithms can be used. And that is used at many places with most of the portfolio that we have. The second, there are many algorithms like clustering. For example, you want to classify parts according to particular categories. And that clustering algorithms are also classified as machine learning algorithms today, and that's been used for a while in our portfolio. There are ranking algorithms, there are prioritizing algorithms. So there are many algorithms like this that would fall under the gambit of classical AI, which is used across product development everywhere. And you would have seen, like what you're mentioning is the user experience where based on what the user is doing, if you can record those activities, then you can, if you have recorded similar activities before, then you can probably anticipate and say, what is the user going to do next? And then provide the user interface which will match that user action. So those are just ways in which we capture historical data and then use an algorithm to do something useful for the end user. So to answer your question, there are many places where algorithms like this are used, and sometimes the user is not even aware that there are algorithms like this is used. So it is not something new, if that's what you're arriving at.
I think that's historically the case. There's, generative design, like we talked about, the, visual part compares, things like that. Those have existed for a long time, and people didn't necessarily think of AI with that. But now that everyone's thinking about AI and that it's on top of mind, how would we expect that the folks that we interact with most often, engineers or manufacturing people, are going to be impacted the most in ways that they'll realize that they're working with AI? How is it going to change what they do in ways that are noticeable to them?
Yes. So let us look at where the technology is today, right? So with generative design or generative engineering, now there's a next level of generative engineering, which is generative experience. So imagine that the engineer is able to come in and then say, give me 1,000 variations of this design, compute 1,000 variations of the design I've made, and then analyze these different variations of the design under various operating conditions. Under customer one operating condition, customer two operating condition, and I create a plethora of operating conditions and ask all the 1,000 models to be analyzed under, let's say, 10 operating conditions. And that is 10 into 1,000 combinations, right? So it goes through all those combinations and then kind of tells you which design in terms of material, in terms of shape, and in terms of dimension. It tells you which exact design is a fit for requirement number 1, requirement number 2, all the way to requirement number 10. And then allows them to choose and say, okay, by the way, I've got some alternatives for you. This is the lowest material option. This is the highest load-bearing capacity option, and gives them choices that they can make for the designer based on all the design permutation combinations that they have. And I think that is very powerful. That's a generative experience because the software is generating new designs for you based on a basic framework that you provided the software. And that's where we are. That's a generative experience. And if you just take this concept of generating new things, you can apply it across product development. And obviously, applying it to design is the most powerful thing. And Dassault Systèmes has invested almost 10 years in this process of getting to where we are. And this is something that every customer should look at today and see how their existing design practices can be accelerated and innovation can be accelerated based on just this one capability. And this is all possible because of the computation power that is available today, right? I mean, the cloud has made high performance computing available to the masses. So now you can do this kind of simulations and plug into the cloud and literally analyze this thousands of combinations and figure out what is the best design for you. So that's the first point, right?
Do you see it as a function of being able to then take real world data, apply performance of the products from that, and use that to suggest new product designs or improvements in product designs? And is that closed loop capability possible with the tools today?
Yes, I mean, this has always been possible. Like you can, if you look at things that you're measuring in a product, if you're measuring, let's say, the pressure, temperature, different kind of things like this using sensors, and you're getting that data, they're just parameters, and there's probably an outcome that you're looking for. Let's say you have a pump and a motor combination. The output you're looking for is probably what is the head of the pump, how high can the pump deliver over long periods of time. And you can probably correlate the operations of the pump in terms of RPM and observed behavior, and then see how long is it able to give you that head, how many cycles is it able to give you that head. And that you can use a machine learning model for that, or other models, other algorithms, and definitely use that to understand behavior of an operating equipment. But designers, predict this behavior up front, right? I mean, when they design the pump and the motor and put it together, they are predicting what would be the temperature inside the motor, for example, and what would be the pressure that is in the pump outlet, and what would be the head is all predicted. So that gives them an ability to correlate between the prediction and the observed behavior. And hopefully they will learn something from this, and that will lead to an innovative capability being delivered by the designer.
We see a lot about the the contextual models of AI, and I'm just wondering. So I think about the disciplines that there are that we work with, and one of the ones that I always think is more daunting for companies to undertake because it's a change in how they educate their people is model-based systems engineering. Is there ways to use AI to simplify the process of doing model-based systems engineering? Is there ways to use these I mean, if you can write an essay or an article or take a law test, can you create system models through AI without having to be an AI or without having to be a systems engineer?
Yeah, I think this is an important question. And if you look at model-based systems engineering, underlying capability in many methodologies, whether you use Diamola or use SysML-based tools like CATIA Magic, there's underlying language that model-based system engineering uses. In the case of CATIA Magic, it is SysML. In the case of Diamola, it's Modelica. And these are very much like high-level programming languages. And if you compare what the generative AI capabilities today can do with software, they can pretty much generate software on prompt. You can ask it for a particular algorithm. For example, for lack of a more complex example, let's say you wanted a function to generate Fibonacci numbers, you could just ask for that, and the software, the ChatGPT software, for example, can generate the code for you. So similarly, it is not very difficult to do the same with Modelica and SysML. So what I'm alluding to is the capability to generate code is possible today, even in the systems engineering arena or any other programming environment, for example. If you go to one of these Gen AI tools and ask for a script in a particular language, it's going to give you the code for the function that you asked for, and that's applicable to model-based system engineering as well.
So you think it's realistic then for a large language model AI solution to generate systems engineering models for us, because behind the scenes, systems engineering model is really just math and programming.
It's programming, basically. Yeah. Yes, it is. I think that's a definite possibility.
So then it's a matter of training the models to be able to do that. Do you know, are any of the folks in our space training large language models to do those things?
Yeah. So if both SysML and Modelica are prevalent on the internet, and it's available today because they are both standards-oriented languages. SysML is definitely a standard, and for lack of a better word, open source, right? I mean, same thing with Modelica. So the large language models have learned these languages already, if I'm not stretching it too far. But there is a level of fine-tuning you can do in a particular domain. For example, if you are looking at models that are built for a particular purpose, for example, motors and generators is the domain that you're interested in, and you're interested in models in that domain. There is a definite possibility to take models in that domain and train it further, fine-tune these large language models further in the models that you're built within your company, and make it more relevant to your organization. Otherwise, one of the issues with the large language models is that I think there are a couple of issues. The first one is that they have a time limit before which they have learned and after which they have not learned. And so anything that happened after that time limit, the models will not know about. But the second most important issue that we should be well aware of is hallucination. Sometimes it can write a piece of code which will look, perfect, but just that it doesn't work, right? I mean, it can generate stuff which is not functioning. So in order to avoid these problems, getting domain specific and getting to a point where you're able to fine tune this model to exactly what you want, and you can preload this with the context. So you can give a context to the generative AI model, which is the context that you want it to confine itself in, and by doing that and prompting better, you can get more effective results. But yes, you have to be careful about the hallucination.
So that's one thing I wanted to dig in a little bit, because one of the things that Eric, when you had posed the question, you had said basically, can you use AI to generate a model-based systems model without having that knowledge? And I think that's the scary part about it, is that people are like, well, wait, is this going to replace my job? Is this like, but you can't, right? That's one of the things that you can ask it to, and it can generate it, but whether or not it's correct is based on the data that it's using, the context that it's giving, and there has to be some level of knowledgeable verification, if you will, and fine tuning. So based on that, like Ramesh, when we're talking about how AI is affecting or going to affect the future of work, where do you see the human aspect coming in? It sounds like it's in the setting up the context, it's in the fine tuning. What are some other aspects? How do you see that changing the way engineers work?
So I think it's a difficult question to answer, but let me say this. I don't see AI as a capability which is equivalent to equivalent to us. It is something that will help us improve our productivity. Right? That's the first thing. My personal opinion. I think it augments what we can do. So you're absolutely right. In order to build a good system engineering model, you need to be a system engineer. You cannot be a novice at it and then try to get generative AI to build a system for you like that. That's I don't know if the generative AI model will give you an accurate model or not, but definitely you need to have the expertise to understand what you're doing and what the generative AI is doing for you. So in that manner, there'll always be experts required to build these systems model, at least in the product development domain. That's how I see it. Now, if you broadly classify how AI is going to help, right? The first thing is AI can help you with situations where you need a self-service agent. For example, you need to ask a particular question, and before you need to go and search for something, or pick up the phone and ask a particular person. And instead of that, imagine that you can go to a prompt and ask a question. For example, what is the maximum stress limits on this part? And then the AI can tell you based on the data that it observes. For example, if you have a design and a simulation within the system, you can answer questions like that. So that's the self-service agent. Or the popular example in common parlance is if you wanted to figure out what is your delivery timeline, you would probably go to a self-service agent and ask the agent, when is my product going to be delivered? And that's a typical use case of a self-service agent. So that's the first case. And I think in our day-to-day lives, we are using the self-service agent more and more, whether you go to a banking facility or any facility today exhibits some kind of self-service capabilities where an agent is answering questions for you. The second level is, I think, where things get even more powerful, where you're able to collaborate with, for example, the 3D Experience platform. You're able to collaborate with an agent. So if you have a common definition of a goal that you want to achieve, for example, you want to do a product design, then you can collaborate with the agent or let's say in this case, the 3D Experience platform, and then achieve that goal of doing that product design together. And there, all the things that we talked about, generative design and ability for the system to prompt you and guide you to various things and also perform calculations on its own and give you feedback and do some work for you is where I think the maximum productivity gains are to be sought. And this is where Dassault Systems is working tirelessly to understand, first of all, how every role in the organization can benefit from this, what are the use cases that they typically go through, and how an AI can augment their jobs. So we are going to look at productivity benefit. And this productivity benefit is going to lead to more jobs. So when a company becomes more productive, history shows us that they get more successful. And because that success will drive, for example, making more products, and that products will require more people. And therefore, you will need highly talented people because of the productivity improvement. That's just an economic fact. So I think it will create jobs in the long run. And if you take the mission of Dassault Systems and look at the broad mission of helping customers build their products more sustainably, and this is huge. Even if you take a simple motor, let's say the motor is operating at 95% efficiency. If you find a way to operate it at 99% efficiency, obviously that's a huge sustainability benefit, right? I mean, you take just one facility like a power plant. It probably has 50,000 pumps and motors. Imagine each one of these pumps and motors is operating at a higher efficiency. Then that makes it more sustainable. So every product that we use, everything in our life can be made more sustainable. Imagine material substitution. Today, people just don't have the time. Engineers just don't have the time to do all this permutation combination, to figure out what will happen if I substitute this grade of steel with another grade of alloy steel, or I take out steel and try aluminum alloys. If I do all these different permutation combinations, you will end up, improving the sustainability because you're going to use less material. Most probably, you're going to probably use materials which are stronger and lighter. So if it's lighter, that means it's going to be more fuel efficient. So the product, not just you're being more productive, but you're able to try out more things. And because you're trying out more things, the sustainability of these products are going to go up. They're going to become better products, and they're going to use less resources, and that's going to help the planet a lot. So those agents are collaborative agents that you work with. Until now, I think the platform in our minds has been two people coming from, let's say, two different disciplines, or engineering and manufacturing, and working together. So that's collaboration. But now we should open ourselves up to the possibility of collaborating with the system itself, with the AI capability, and collaborating and working together to achieve a goal, let's say more sustainable product. Now, the third step of this, I think, is where there are instances where a process or a sub-process can be completely automated. There are various tasks done today, and many of these tasks could be highly manual. And those tasks could be done almost in an automated fashion when you put the classical AI and the generative AI large language capability together. For example, in data science, we have a typical process that we look at, which is the defect resolution process. One of our customers has more than 3 million equipment that is operating in the field, and they get about 20,000+ incidents that happen on their equipment on a daily basis. Imagine that you're getting 20,000 incidents every day. So you need to, understand the incidents are not issues. Not all of them are issues. But being able to go through those incident reports and then figure out what is issues. And the important thing is that this customer is in a regulated environment. So if they really find a product-related issue, they need to report it to the regulatory authorities within 9 days. So imagine that situation where you're getting 20,000 incidents a day. You need to triage these and figure out what are real issues and what are not. And the next step is to prioritize these issues and then locate those issues which are product related or manufacturing process related, regulate it, and then report this to the authority. That activity itself is very time consuming. And these are things that classical AI plus a large language model can do very well. And it can help you sort through and make sense of these issues and incidents. The next steps that you can take in the automation process, but maybe I should pause. Sorry for that long answer.
No, it was a good answer. It's, matter of fact, the last piece of it made me wonder, like, how are we ever doing any of that without AI?
Well, the other thing is capturing commonality of that, because if you've got one thing that's repeating a lot, you don't have one person or even just a couple people going through 20,000 issues a day. You've got a team of people doing that, and it's hard to find commonality across a team. Whereas a single process that's looking at all of those can bubble that up, just like you can use something like ChatGPT to summarize 50-page PowerPoint to two slides, being able to take 20,000 incidents and summarize where the problems exist and what the most pressing problem is would save a lot of time and I would think reduce a lot of liability or exposure for the company.
Yes, absolutely right. And you can take it a step further. So if you give access, so this is where the platform is very important. Doing data science piecemeal is not as effective as doing it on a platform because of this reason, which is now if I can give access to the large language model to past history of issues that were resolved and past history of all the failure modes that were predicted and things like that, then the model can go ahead and do a root cause analysis by itself and can give you and say, this is the issue that came out on the top, and here are possible root causes for this based on what we have observed in the past. Obviously, it may not be completely accurate, but just the ability that it can take an attempt at that and give you a starting point for the quality engineer to work on could be tremendous productivity benefit.
So it can actually go through the simulation plan then and determine what simulations were insufficient to have found that problem and isolate how we need to improve our simulation and testing going forward, as well as looking back to the design and identifying where maybe the design flaw was?
I think the answer is yes. I've not analyzed that particular topic in depth, but I have to say that why we are able to do that is because if you have a platform where you have both a data science framework, and you have the predictive model, and you have the ability to, in a secure and safe way, bring these two worlds together, then you can potentially generate that for you, and it will be able to look at the predictive models and say, this is what was missed out. I think that's what you're asking for, right? So yes, that's possible. Just to let you know, the Dassault System platform, 3D Experience platform, is both the modeling, simulation, or a service-oriented architecture, and the data science platform. The data science capabilities have been maturing over a period of time. Now it can start tackling things like that we are talking about right now because it has got both the capabilities in the same platform.
So to define data science or data science platform for us, because that's not really something that we've talked about. That's not something you hear as much. So you hear AI, but how's data science and a data science platform differ from that?
So imagine you have got various algorithms that you're working on, and you've got various sources of data that you're working on. And this data could come from within the 3D Experience platform or from outside. And you want to be able to get this whole environment organized and controlled in a manner that you're taking raw data, you're cleaning the data, and you're blinding the data, or you're making the data more useful. And the next step is to take it through a data pipeline where from the data, you're exposing it to, let's say, to a machine learning model, and then doing a categorization using a different model. You could go through a various steps in a pipeline, and then to get to your goal that you want to achieve, which is probably a prediction that you want to do, and then make this prediction possible through a perspective of a user. So when the user is looking at this, they are exposed to this capability in the context of whatever they are working on. For example, if I'm a quality engineer, I am trying to put a root cause analysis together. And when I'm trying to put the root cause analysis together, the system is able to recommend some of the initial root cause analysis that it's able to identify in that context. So there are three aspects of this. One is to make sense of the data and make it more valuable. The second is push it through a pipeline of algorithms to make the prediction. And third is to manifest that result in the context of the user's prompt and in the context of the work that the user is doing. And all this put together, to me, is a data science framework. And that framework is part of the 3D Experience platform. I mean, there are a lot of companies out there and also a lot of open source tools out there which do the data portion of it and they do the algorithm portion of it. But providing this whole thing in the context of the user is what I think is the most powerful with the data science perspectives that 3D Experience is delivering. And obviously, the pipelines and algorithms that are using are highly tailored towards product development. So the domain focus and making it work in the context of the user are really important tasks. I hope I'm able to differentiate with respect to
So you're saying it's taking the general data, conceptualizing it, and applying it to the process or the problem that the individual user is having at the time. Is that? And
making it appear or manifest itself in their perspective. To give an example of a perspective, let's say when you take a Uber, you're looking at the same data. You and the driver is also looking, you as a passenger and the driver are looking at the same data. But the way you look at the data is very different. You look at a different set of, it manifests itself in a perspective for a passenger. And when the driver looks at the same data, it's showing all the capabilities that are required for the driver of the vehicle. So same way, when as a role, if I'm a quality engineer, I want the analytics. If I see a graph in isolation, it means something less relevant to me than if I see a graph in the context of the part that I'm working on, in the context of the issue that I'm trying to resolve. So that bringing it in the context of the user, I think, is very important.
So one of the other things I think about, so we've talked a lot about AI and how it impacts the user, the engineer or the design engineer or the manufacturing engineer. How is those folks having these tools or the companies having these tools, how does that manifest for the customer? I mean, you talked a little bit about it impacts environmental and makes things more efficient. I assume that means that products can get out more quickly or maybe better quality or less cost, but are there other ways? I mean, I always think, and maybe this isn't realistic, but I want to, have a headset and I want to say, I want this kind of product and I want it to show me what that looks like. And without knowing anything how to design it or what's behind it, get something made for me the way that I want it, the color, the shape, the power that I need it. So is it realistic to expect that things like AR, VR, mass customization are all ways that AI will be used to change consumers' interaction?
So, yes, I think you're spot on. If you just take the generative design or generative engineering capability, what it means to the end customer is that they're going to get a more specialized product that is applicable to their environment more often than before, because engineers can try out different combinations now. That means they can pick out something that will work for that specific customer in a more appropriately. The second thing that is important, what you mentioned also, is that when the enterprise processes become more sustainable and they work towards getting a sustainable product out, the beneficiary is the customer. Imagine that a motor works more efficiently, then the beneficiary of that is the customer. They're going to have reduced operating costs by operating that motor. So that's a that's a win for the customer. And finally, I think in the future, any product today, you see, every product that we are working with has got some kind of capability to collect data and have a connectivity to the internet. So that's kind of a norm today for most of the new products. But imagine in the future, there is also capability of that product being able to respond with the agent itself. Let's say there's an agent embedded within the product. And product development, the next generation product development would work towards embedding these agents within the product. That means you could maybe talk to your refrigerator and say, please set your temperature to this. And it might do it. So that's a product development activity. And because we have these models that are becoming ubiquitously available, it's a matter of time before these systems will connect to the internet and probably take a voice prompt and be able to, be more better. It will be better in terms of user experience in the future. So that's also, the consumer is going to benefit from that. The customer is going to benefit from that, from the new R&D that's going to happen in this field.
Excellent. I'm looking forward to my IKEA furniture being able to assemble itself.
Yeah, I don't know if that'll happen. But
that's robotics. That's the next section, Jen.
Probably not. All right. So I want to be cognizant of our listeners' time. I think we're running a little bit long, so I want to take a quick minute to summarize. This has been a fascinating conversation. We've gone through so much. Talked about some of the benefits that AI is bringing, both in the ability to innovate more quickly, to be more productive, and then also to create more sustainable products and sustainable processes. Matter of fact, that all relates into or becomes better products for the end consumer, and hopefully at a lower cost, although I'd be happy if they just stayed at the current cost rather than going up. Well, one of the things that really struck me listening to the conversation was not just the increasing amount of data that we're talking about here, but also the increasing importance of that data being correct and not just right and precise, but also the context of it being so important. Because to your point, Ramesh, you had mentioned it's the same data, but your view into it and how you see it is different based on what you need to know and what you need to do with it. So those are, I think, all very important points. Is there anything else real quick before I, wrap up? Is there any final points that you wanted to make that we didn't cover?
Yeah, I think, this is an exciting conversation and we are just at the tip of the iceberg. There's more to come. And it's going to become more easier for our users to adopt our technology and to use it much more effectively to improve their productivity and the sustainability of their product. So I'll leave it at that.
I agree. It is a fascinating topic, and it wouldn't surprise me at all if we have you back on in another several weeks or a couple months to talk about, okay, now what are we seeing? Because it's also a very quickly moving topic.
Yeah.
But hopefully we're able to dispel some of the fears because it is a scary topic as well. So anyway, as we wrap up, I want to thank Eric for joining us today. and Ramesh as well for exploring what the future of work may look like with AI. And to our listeners, if you have any questions or would like to share your experiences, if there are any topics that we didn't cover today that you'd like to see us cover, please reach out to us through social media channels or our website. You can find the podcast wherever you like to get your favorite podcasts. But we would love to hear from you. We'd like this to be a conversation. And until next time, stay sharp.
Thanks for being here and listening to this episode of Stay Sharp with Razorleaf. If you have any questions about this episode on AI and data science, we'd love to continue the conversation. Just leave us a comment on our post or send us an email at podcast@razorleaf.com. We appreciate all the feedback we receive from our listeners, so don't be shy. Make sure to subscribe to our podcast on your favorite podcast platform or on our YouTube channel. Until next time, stay sharp.